Assalamualaikum everybody. This is Roman Karim and today we'll be presenting our DBMS project. The name of it is Tectonix. It is basically a resilience and smart disaster management system. So this is basically the landing page of our project. And if I click on login or sign up, I'll be introduced to this page. Currently, due to lack of space, it is kind of lagging, but it's not supposed to lag. It's really smooth. And I can either create an account as a citizen or a specialist or maybe a volunteer. If I become a volunteer, I have to select my proficiency level at volunteering. I can even become a first responder, which is basically the firefighters. I can select my blood type from here. And I can also become a building owner. And then I have to select the owner type, which can be individual, corporate, or government. I already have a building owner account created, so let's just log in with that. So this is basically our dashboard. Here we see the number of active sensors, which is basically the number of active mobiles. Also, we see the buildings monitored. We also see the active alerts. Now here in the live real-time map, we can see that the mobile device sensors are picking up different kind of readings. The readings are basically the vibrations the mobile phones are recording, and we save them to our database and show them on the map. And the red zones are the zones where there are lots of risky buildings. You generally want to avoid those areas during disasters. And that's basically it. We're currently just covering Dhaka for the moment. And inside alert feed, we see the disaster alerts. We also see rescue alerts. We also see seismic activity, which comes from the mobile phone sensors. And just below that, we see the risk distribution. On top, we said we were monitoring 34 buildings. Out of 34, we gave each one of those a risk score. Now, out of them, 10 were marked safe and 11 were marked high risk, and the rest were marked moderate risky. And on the left, we have a recent seismic activity. This basically tracks the devices and whatever their readings are at different time of the day. This basically shows the last 24 hours reading. And just under that, we have the recent sensor logs, which logs all the devices and the status of their readings, as well as their timestamps. And just after that, we got the seismic mode. I'll show this with our mobile app. And we also got the emergency beacon. If we click on activate, it's going to take our GPS location and send an alert through our database. And our specialist will see this and can assign people to rescue this person. I'll show that in a bit. Other than that, we also have a retrofit cost calculator. If we select any of the building, we have to select either commercial or residential. Then let's click on next. And after that, we have to select the square foot and number of floors we have. And after that, from our database, we can select all the materials that we might need for the retrofit. And we can select how many we need. We can add more. And after that, we can get a simple estimate from here. If we click on save, it's going to be saved to our database. And if there's any issue in our building, we can upload a photo of that, select which building the issue was in, and use GPS to get the coordinate and describe the issue and the severity level. And just press and hold here to submit a report damage. Also, we got settings over here. This is basically common for all the users, where they can see their email, their names, the type of user they are. If they're a building owner, they can see also the registered properties they have. They can also change their password from here as well. Now, they also got Building Asset Manager, where users, or rather building owners, can see the buildings they own. They can select and check the risk score. If they create a new building, the risk score is unverified, and it will be verified after the specialist verifies it. And if users want, they can also change ownership of the building. They can give it to some person else. And they can also select the date from here. And if somebody gets a new building, they can add a building to our database from here as well. Just click on use GPS to get the GPS location and put in the building name and address and click on save building. It will be stored in our database as well. Now for the seismic mode, I'll just go to my phone to show this. We also do have a mobile app, but the backend being locally hosted, it's kind of pain to build the app again and change the server location. So I'll just show you guys the browser version for now. But we also do have a mobile app. We just need a proper server to host it. For the moment, I'll just show the browser version of it. So here's the browser version of the app. We see the map and everything here as well. And if we go to the seismic mode, we can see that we can activate the sensor from here because this is a phone. We have a sensor sensitivity as well because every single phone doesn't have the same kind of sensors. Some are really cheap, so they can adjust it from here as well. Now, as you can see, if I move one device a lot, it's gonna detect the vibrations, but it's not gonna send an alert because people do shake their phones a lot and we cannot record that as an earthquake. So if people shake, we just send that to the database. I have also kept the console here to log. And as you can see, we are sending the information to our database. This console is just for the developers version so that I can track if the data is actually going. As you can see, it's actually going. And the logic behind this is if basically 50 devices or 100 devices in an area shake at the same time, we then log an earthquake. But I don't have 50 devices, so I'll test with 2 devices. I'll set the sensitivity to low on both. So if I shake both the devices at the same time, I should get an earthquake alert. There you go. Now, the main logic behind is this: if 50 devices or 100 devices in this area shake together at the same time, we save that in the database and log an earthquake alert and send it to every device. And that's basically it for the seismic mode. Okay, now we signed up as a specialist. Now we can see a few different options over here. Inside rescue coordination, we can go and see the active beacons as well as the active incidents. If any earthquakes happen here, it's going to show up here. And if any activated beacons are here, it's going to show up over here as well. If the problem is solved, we can click on resolve and it will resolve the problem and save it to our database. But if the problem still is there and we need to set personnel to go on the mission, we can simply click on assign and assign the people we want to send on this mission and click on deploy. There you go, deployment successful. And then those people will get a notification to go on this mission. And there's also this AI scanner where the reported damages building will show on top and the normal newly added buildings will be shown at the bottom. Now, if we go to any reported damaged buildings, we can also see the view proof and the pictures and videos the building owners have given us. And from here, we also get the liquefaction risk, moisture, water table. All of these are fetched through an API and saved to our database. And the basic idea is that the specialist will get additional information like this on his screen, but he has to physically go and check the buildings, the newly added buildings, as well as the damaged ones. And from here, he can further upload the image of buildings. Let's say he selects one from here. Boom. And after that, he clicks on scan image. It's going to send to our AI engine. And the AI engine is going to check how many windows are there, how many doors are there, and it's going to give a score back. And the person needs to manually verify it through his eyes, physically being on site. And after that, with all the soil risk and the AI visual score, he can define a score over here that will be saved to our database. And there you go. And that's basically it for the specialist. And now let's go to the responder part. Okay, now here in the volunteer part, as you can see, volunteers can also add up skills. and the level of proficiency with that skill and add it to their profile. And they also get an option, My Mission. If they go here, they can see their active mission and their active assignments. And when they accept a mission, they can simply click on Accept Mission and it will be updated in our database. They can also select Start Route, arrive at scene, and complete it once it's done, and that mission will be completed. And it's all gonna be saved to our database. Now, let's say he needs to know the location of this mission. He can also click on Navigate. It's gonna take him to his Google map and it's gonna help him to see the direction to that place as well. And basically, that is a small demonstration of our project. I hope you liked it. Thank you.